Good day, my students. Welcome back. I want you to sit back. Let's enjoy this class together. But before then, I want to welcome you to Eko Learners Support for WAEC and NECO candidates. My name is Odusatolokwe Joseph, your instructor for today's class. Shall we go? Or shall we dive into the words? The class. Let's go. Never mind what you are saying there. I'm only trying to what? Wow you into a chemistry class. This is all we do in chemistry lab. Let's go. What are we going to be discussing today? Basically, we call it what? Fractional distillation. Under what? Crude oil and hydrocarbon precisely. But what is going to be our objective for today's class? Fine. The first one will be to define what we call fractional distillation. Second one should be describe the key steps in the process of fractional distillation. Then lastly, explain how hydrocarbons of different sizes are separated to form a useful product. Good. These are things that we're going to be talking about as we move on with the class. I hope you are following me. Let's go to the next slide. So what is fractional distillation? You will agree with me that when you were in SS1, talk about what? Separation techniques. It's one of the what? Components of what? Separation techniques. And what do we use fractional distillation for? To separate different components that are physically mixed together, and they can easily be separated into different components and still retain their what? Individual property. But this is based on their close boiling point. What did I say? Close boiling point. So it's very key. Let me pick my pen. Close boiling point. Therefore, fractional distillation, according to what I have on the board, is a process used to separate out the mixture of different size hydrocarbons. Hydrocarbon precisely in crude oil. They are separated as their evaporated vapors condense at their boiling point. Never forget. Why is this so essential? It's because those components are what? Are physically combined together. Therefore, separating them make it fine for us and make their uses still retain, because they will still retain their what? Their property when being separated. Okay, good. Now, also, don't forget this fractional. The fraction there is telling us that those components have what we call a close boiling point. With that, I think we can go ahead and move to the next slide. So let me undo my pen and go to the next slide. We now need to come to a point where we need to define different terms used in what? In fractional distillation. The first one is hydrocarbon. Hydrocarbon. Two things are involved: hydrogen and carbon. Only. Therefore, it's a compound containing hydrogen and carbon only. Is it only that? No, not only that. You remember, fraction. What is fraction? You remember in your mathematics, something that has numerator and denominator. Example could just be 1/2. Something very small, very, very small. Therefore, we say hydrocarbons with similar what? Boiling points. Some textbooks will put it close boiling points. Close what? Boiling point. In that case, fractional distillation basically is used to separate different components. Remember, the components are what? Miscible. Miscible. What do we mean by miscible? Something that's, like ethanol and water. You cannot easily know if water is contained in the what? In the ethanol, except you use their boiling point. Fine. So, with a close boiling point. Not only that, crude oil itself is a mixture. This word is so important. A mixture, something that is what? Physically combined together and can be separated into different components and still retain what? Their individual properties. Yes? Mixture of what? Different size hydrocarbons. Nevertheless, something must happen, when you heat heavy hydrocarbon into lighter hydrocarbon, then you condense it to get it back. For example, is your petrol. A petrol, you don't know. Is a what? A volatile liquid. What does it mean? Let me tell you what I used to tell my students in the class. If you want to know, buy a petrol of 25 keg and of 25 liters and expose it. Don't cover it up before tomorrow. Go and check. It should have increased in size. Or what is it? Decrease, disappear. You have to confirm that yourself. Good. What? But it's in form of liquid. How come? It's through condensation. So this vapor are condensed. Back to what? Liquid is essential in what we want to talk about. Therefore, with this, we can go to the next slide. Fine, let me undo my pen and let's move to the next slide. What's happened to our crude oil? You need to get to know. Yes, you need to get to know what happened to our crude oil. Fine. You know what the crude oil is? I've told you. They are heavy hydrocarbon. Fine. So we need to heat this crude oil in order to separate it into different components. We take it to what we call fractionation what? Column or what? Fractional distillation. It may be. So at the bottom, what happened? The crude oil enter. So when it enter, the crude oil is being moving up. Why? Because we are heating it. When it is heated up, the vapors, they rise. They are going through the what? Different fractionation what? Column. These are fractionation what? Column. This is column 1, 2, 3, and 4. Going up. What happened? Let me undo my pen again. You discover, after they've gone up, with the result of what? Eating, they are coming back. Why are they coming back? Because we want them in a liquid form. So the process of coming back is what we call condensation. So we are condensing the what? The vapor into liquid. So you can have it in your house. For example, kerosene, petrol, diesel. You get to know all this as we move on. So you remember the first one is heating the crude oil. When you heat, turn to vapor, it goes up. The second one is you're condensing it by turning it to what? Liquid. And when you do that, it comes down as what you have. The hydrocarbon vapors condense once they reach a what? A fraction below their boiling temperature. Don't ever forget that they have a close boiling point. So when each of these particular gas get to their boiling point, you condense them back to the liquid. Is that the case? What happened again? So let's see what happened again. Good. You see, the liquid what? Leaves. So the hydrocarbon, the liquid hydrocarbon fraction, leave the column at different heights based on their what? Their boiling point. Oh, let's see what it is now. Oh, good. So at the end of the day, we are able to get what? Our products from crude oil. So the liquefied what? Petroleum gas is the first one you have. Oh, good to have that for cooking and eating. So fine. Then you have the what? The next product called petrol for car fuel. Good. Not only that, for your generator. So you have the kerosene. Good. So this is the kerosene. For what? Aircraft what? Fuel. Then we have the diesel for car, train fuel. We have the heavy fuel what? Oil for ships and the what? Power station. Then we have the bitumen for road surfacing and roofing. Yeah, these are all the components of what? Crude oil. I want to give you one simple assignment. Just go to the what? Filling station. All the products you see in the filling station, from the petrol, to the diesel, lubricating oil, and what again? Any other thing there, they are all products from what? Crude oil. How do you do that? To confirm that what you are actually using or selling in what? In the filling station, the products from what? Crude oil. Okay, fine. Let's move to the next slide and see what is there. Let me undo my pen. Just to explain what we've seen so far. So the process explained different what? Size. Hydrocarbons have different boiling points. We know that, and the boiling point is close. Not only that, but the question here is, why are they having what? Different boiling point? This is because the larger hydrocarbon have stronger intermolecular what? Forces. You know, when you say intermolecular forces, we are talking about force that is between the molecules and bring these molecules together. And for you to separate it in crude oil, it requires a lot of what? Energy. That is why you have to heat your crude oil. Yes, very, very well, in order to separate it into different components. Now, at the top of the column, what do you have? The smaller hydrocarbon. Because this is based on their own boiling point. So the one with the lesser boiling point will first evaporate and get to their boiling point. And that's what you see. Low boiling points. And they flow easily, like a petrol. Ignite easily. Don't try it. Don't take a petrol close to the what? Fire. You get burnt. Don't try to do that. Then they are volatile. I told you earlier, when it's open then, without closing them tight, before you come, what happened? They disappear. They don't wait for you because they are very, very volatile. So what happened at the bottom? They are still heavy hydrocarbon, e.g. diesel is very heavy, bitumen is very heavy, asphalt is very heavy. So what happened? Because they are still having what? Yes, heavy hydrocarbon, and therefore they have what? High boiling point, because the intermolecular force between them is still much stronger, and you need a lot of heat to break them down. They don't easily evaporate or easily flow, or yes, easily what? Flow. Like your diesel, the way it flows is different from the way your kerosene will flow. Good. So they don't ignite easily. They don't easily catch fire, and not even volatile. So these are things that you need to know. Now let's move to the next slide. So at the end of this presentation, we are still talking about fractional distillation. I just explained, but good to know that, fine, after knowing this component, I need to quickly explain something so we can move as far as possible to be able to get what we want to get done before the next class. This will be so essential in your next class. So we just want to explain the formula of organic compounds. You are familiar with it? You have the empirical formula. I hope you know what the empirical formula is called. The actual words, atom. You can see in a compound, the actual atom, the actual whole atom, you can see. Why the molecular formula? This one is talking about, yes, the molecules of this atom in a compound. Let me give you good examples of this empirical formula. If I have C's, H's, and the empirical formula here, the smallest atom, Cs can be divided by both. So if I do this, I have CH. So basically CH simply means here the empirical words formula, the smallest O ratio. Are you fine? Good. Empirical formula. Then C's, H's becomes the what? Empirical formula. Then the structural formula. We need to go into structural formula. So on this note, I need to move very fast. Okay, fine. So the first member I pick here, good, is alkanes. Alkanes, you know, I'm just basically to talk about the empirical or molecular and structural formula. So in this particular case, what you are seeing here, you are seeing their condensed form and their what? Their chemical formula. You have CH. So at this point, when you see something like this, it's CH4. So what's the name called? Methane. In this, when the carbon is 2, under this family is called what? Ethane. When it is 3, propane. So when it is 4, butane in that particular direction. And you could see, I've told you earlier, that the carbon is what? Tetravalent element. So if you have something like this, all I need to do is to support it with how many hydrogen? Yeah, 3 hydrogen, yeah? Yes. So this is structural formula. Why this is what? A molecular formula. And when you look at the carbon, it's being surrounded by how many bonds? 4. So please, I want you to just try to understand this. Good. So let me move to, so you can have, this is the ball and stick what? Structure. And that is what? The Lewis structure for this particular compound called what? Butane. They are still the same direction. Then most of the words common are key substituents. Yes, in naming the organic compound, we have what we call substituents. So what are substituents? They are the one you see as a branch in a compound. So it could be from alkyl. This is different from CH4. Don't forget, CH4 is methane. But the moment you remove what? One H from that CH4, it becomes what? Methyl. And this follow this particular order. So when you see all these alkyl cannot stand on their own, they have to be as what? As an attachment to what? Hydrocarbon. Good. We can move. So look at this particular example. You had to name this compound. You had to name this compound. So the first thing you have to determine the what? The longest continuous carbon chain. What do I mean by longest continuous carbon chain? A chain without what? Breaking. You don't break them in the middle. So you can either go this way, 1, 2, 3. You can go 1, 2, 3, 4, 5. Or you go 1, 2, 3, 4, 5, 6. You discover that the longest continuous carbon chain here is 6 what? Carbon atom. Then what happens to this? It becomes attachment. Don't forget, when you have carbon 2, it's called ethyl. So if I'm to name this compound, how will I name it? Which family it is? It's the family for what? Alkanes. Okay, good. So if I'm to name it, it becomes 3. At position 3, I have what we call what? Ethyl. Then 6 carbon. 6 is called what? X. So become hexane. So simple. 3 ethyl. Why is it 3? Because this attachment is on carbon 3. Why is it hexane? Because it has 6 carbon what? Atom. Good. So coming down here, the same scenario, you have to name the words. Longest continuous carbon chain. Is either you start from here, 1, 2, 3, 4, 5. Or you start 1, 2, 3, 4, 5. So you discover if I start from here, this becomes attachment. And it is on carbon what? 2. But if I start from here, I have it as carbon 4. You have to look at the closest what? Attachment to the longest continuous carbon chain. You discover that 2 is better than what? 4. Then you should go in this direction. Then if I am 2, this becomes methyl. So at carbon 2, say I have what we call methyl. Then what's the parent carbon? 5, that will become pentane. Why is it pentane? Because the family is alkane. Because the family is what? Alkane. So I have 2 methyl pentane. Are you getting that? Good. Then let's move to the next one. Let me undo my pen. Go to the next one. Okay, on this particular one, you had to name this compound as we're rounding up. So if I'm to name this compound, you look at it, where should I start from? If I start from here, I will have it at carbon. This is 1, 2, 3, 4, 5, 6, 7, 8. And one might want to go like this, 1, 2, 3. It shouldn't be. So at carbon 3, I have first attachment. On carbon 5, I have another attachment. So if I come from here, 1, 2, 3, 4, 5, 6, 7, 8. You discover that at carbon 4, I have my first attachment. And you remember the closest was, yes, attachment to the group mattered to you, to the longest continuous carbon chain. So I have to start from this. At carbon 3, I have methyl, good of me. Then at carbon 5, what do I have? I have ethyl. Then how many carbon atoms? 8 carbon atoms. So you have to start naming them alphabetically. So I have 5 ethyl. Then I have 3 methyl. Then which name? Alkane. 8. 8 becomes octane. Good. So the name becomes 5 ethyl, 3 methyl, what? Octane. Then on this, you can do this as well. So if I'm to start, I start from here. So I have 1, 2, 3, 4, 5, and 6. So at carbon 2, I have this, and I have this at carbon 4. So at carbon 2, I have what we call ethyl. Then at carbon 4, I have what we call ethyl again. Then the carbon atom is 6. Because they are the same attachment, I will call it 2,4 diethyl, then hexane. Good. So why is 2,4 diethyl? Because the ethyl is occurring in 2 places. Good. So let's quickly see what the next slide has for us. Yes, I'll give this as an assignment, or let's quickly round it up if we can. Good, it has been numbered. So 1, 2, 3. At 3, I have what? Methyl. And at 4, I have what? Ethyl. At 5, I have what? Methyl. So that will be 4 ethyl. Then you have 3, 5 dimethyl. Then what? Nonane. Good. So it means at position 4, I have ethyl. At position 3, I have what? Methyl. At position 5, I have methyl. Then putting them together, we give you what? Nonane. Good. So, so far and so good. I hope you've done well in this fractional word distillation and naming of words, organic compound. On this note, I want to say I appreciate you for listening.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
You have any question, comments, or suggestion? We want you to use the information displayed on the screen to reach us. I remain your host. Thank you and bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.